All right, so today, the 18th, I have a special announcement to start with. Thank you to Mr. Tavella, or more so his mother, sent in this sweet mason jar that actually, if I make it live up to its full potential, So, who can identify, aside from lights, what is actually in this? You know? What kind of corn? Indian corn. What's special about Indian corn?
It's multicolored and it can be. There's a lot of things. Native American corn?
Yeah. Don, tell us a couple things about Indian corn. Check it out.
You can hang it up and use it for decoration. It's really cool. And then they used to use it, like, grind it up to make food out of it, and they wouldn't just eat it like that because it's really hard. So
yeah. So Indian corn's way different than regular corn. I don't know if the camera can see it or not. But, so Indian corn, they would normally not eat like regular corn. They would normally grind it up and use it to make other various kinds of food. So, as part of our fall canteen next week, we are going to have a guessing game. No one knows how many kernels are in here right now. Nobody knows. Dom's mom filled it, or Dom, I don't know who filled it. But there's a tiny bit of empty space, but it's almost all the way full. I have no idea because they just delivered it to us this morning. So it is going to be up to you to make a prediction of how many how many Indian corn kernels are in this jar. So you have, and I will tell you, Google is a bad resource. Every time we do this, people try to use Google and it always comes out to be way wrong. So you have up until next Friday at our canteen to make a guess for this. Then I think I'll probably find out if anybody would want to take like 10 minutes during the canteen to count these out, and then we could announce who the winner is at the canteen. So, okay, talk to me next week. So, you can come up at the end of class. I'm not answering questions that are off topic. You also have talked about 4 times without raising your hand. You have, after class and all next week, to check this out. I will have a list starting Monday for you to put your guesses on. So today, just observation, whatever you want to do. There is a lot of math that can be used to solve it, and yes, I will be making a prediction. Also, now here's where this steps up a notch. The winner of this prediction, the closest, I don't think we'll go Price is Right rules. I think we'll go just the winner, the closest guess, the least percent error is going to go home with a $25 gift card. So, Dave & Buster's. So that also is big thank you to Dom's mom because I don't have the money to do that. So she was like, hey, can I send this in and can I send a prize with it? And I was like, well, yeah, sure. I'm not going to say no. So check it out. Make your predictions. Use whatever math you want to. There's $25 to Dave & Buster's on the line. Yeah, not right now, but outside of class, yeah. Yeah, you can manipulate it, move it around, count it. I mean, I don't care what you do. You cannot open it. I don't care. So, today we are going to discuss proportional relationships in equations, and we talked about this really briefly yesterday. So the first thing I want you to do is highlight this M in your equation. And I want you off to the side to also write y equals kx. Because there are other various versions of this equation that use k instead of m. Dom, do you have a question?
Yeah, so about like the TV. Is T4 homework?
Yeah. Oh, sorry. I forgot to type it in that line. It's over on the homework board.
Yeah, I know. That's what confused me.
Yeah. My bad. Just forgot to type it in. So the equation up on the TV shows y equals kx. We use y equals mx, and there's a reason why either of those could be used. Who passed out the notes? Where's the extras? Right there. Why, if you look up on the TV, do you think they use the letter K? Tom? constant of proportionality. So, if I was you, I would underline, highlight constant of proportionality. Probably because it looks too similar to a number. We don't really use C for much. And it's the cent sign. I mean, I could probably think of a variety of reasons why we would want to avoid that. Now, the reason that we also use an M is it is a multiple. So whether you use K or whether you use M, it doesn't matter, because we're going to actually replace that with a number that we find by doing the Y value divided by the X value. So if you have a corresponding X and Y value, you can find the constant of proportionality as long as we know it has direct variation. Now, when we looked at the graphs yesterday, or 2 days ago, whenever that was, what was really important so that we know that we have direct variation, we know we have a proportional relationship. Seems like a good morning to use cards. Seems like a lot of our hands are glued to the desk. You're the only person I've spoken with yet today. So I appreciate your involvement, but I got to talk to other people. Ashley, what was one thing that the graph of a proportional relationship had to have or had to show? So it had a unit rate that we could find based on a specific point. Julian, what else? A graph? That any graph could have a title. It wouldn't necessarily have to be proportional if it has a title. Evie? Has to start at the origin. So if we set up y over x at the origin point, well, that'd be 0 over 0? You can't do that. So we don't use the origin point. We have to use a y and an x that have values. But in order to use this y divided by x, you have to have a straight line through the origin. So once I find then a point with a y and an x, I can find my constant of proportionality. I'm coming to you in just a second. Now on the flip side, sometimes your constant of proportionality is given to you, and then you're asked to solve problems with it. So in this situation, this 8.5 is my constant of proportionality. So your friend uses this equation. Sorry, Jeremiah, you got a question.
I was going to say, do you think they're ever going to find a way to solve 0 over 0?
No, because it doesn't make any sense. No one's trying to do it because it doesn't make any sense. The only things that we do, like mathematically, are problems that need solved and make sense to solve. So like 0 divided by 0, and Siri tells you this too. This situation doesn't make sense because it's like I have 0 pizzas now, and if I give them to 0 people, how much does each person get? You can't ask that question because that question doesn't exist. There's no pizza and there's no people. So the people that don't exist can't get the pizza that doesn't exist. The question doesn't make sense. Does that kind of make sense now? Like, that's a weird question to ask. But, so, your friend uses this equation. Y equals 8.5x to calculate the cost y. So he's saying the cost will be 8.5 times the x number of movie tickets. So this movie tickets is my independent variable. It can change on its own. So if you really want to get the most out of this lesson, I would notate that this is my independent variable. And y is actually my dependent variable. Y depends on x. So what is our constant of proportionality here? Ozzy, do you know? It's 8.5. It is whatever multiplies by your x value. I'm going to make that green. Just not confuse people. It is whatever multiplies by your x or by your independent variable. This will not always be an x, but it's whatever the input is. So my input for this problem is how many tickets I'm buying. What multiplies by that? The 8.5. Which really, in this situation, if you want to be accurate, would be 8.50 because we're talking about money. What does the constant of proportionality represent in this situation then? I kind of just gave this away. Jeremiah?
The money? How much money is being used for each ticket?
So the cost of each ticket, or the cost per ticket, which is our unit price. So this goes back to our unit rates. My constant of proportionality is just my unit price. Because how much will it cost if I buy 0 tickets?
$0.
0. And then how much will 13 movie tickets cost? So we set up my dependent variable y will equal the 8.5 times the input or the independent variable of 13.
Oh, wow, that's a lot.
That will come out to be
110.
So if you bought 13 movie tickets at $8.50 a piece, you'd spend $110.
That's a lot.
Monis?
Why did you put 13 in the X, please?
Because that is, so the movie tickets is my input. It is my independent variable. It tells me that X represents the number of movie tickets. So now that I know the number of movie tickets, I replace the X with what I know it is now.
Oh, and
So in the problem, it tells me the Y value is your cost. The X value is however many movie tickets you're buying. So the Y depends on how many tickets you buy.
so if you were doing it this way, wouldn't 8.5 be the cost of one movie?
Cost per ticket. Yeah. Evie?
How much do tickets usually cost?
Depends on the movie theater. In Coshocton, like where I'm from, where I go camping, we're going camping this weekend, so I might watch a movie. I just need like a little vacation. I love you guys, but work gets stressful, and fall keeps like running forward, conferences and everything else. So I'm going camping, making some good food. I'll bring you guys some pictures. Their movies are as cheap as $2 a ticket for a matinee. It's an old movie theater. There's not much operating expense. They employ like maybe a dozen people. At like Rave Cinema over at Polaris, if you go to watch a 3D movie there, anyone? I mean, I don't even know how much. $13.50 for a ticket. You can go to Marcus Cinemas, which is a bit cheaper. There's Movie Tavern. You can eat dinner while you watch your movie. There's Easton AMC. There's a variety of movie theaters and various prices based off of them. Sean?
You can actually value dinner at Furby's.
Oh, okay, nice. Yeah, I don't go to the movies very often because, quite frankly, when I look at the math of it, it's a giant waste of money. Now, here's the argument. You're paying for an experience. If I want to pay to watch a movie, I'm going to rent it on Redbox or Apple Movie or whatever. But if I want to pay for an experience, then that's up to you how much an experience is worth. Solomon, thank you for raising your hand, sir. It's just now it sounds like Marcus is kind of copying their idea. It's a place where you can like buy dinner and drinks and whatever else while you're eating or while you're watching a movie. So you flip a little light, like literally you sit in big armchairs, like leather rolly armchairs.
But the thing is, like, they don't
Yeah.
have very good service. Because my dad ordered curly fries.
Yeah, it does take a little while. I mean, it's a big place. Think of how much food they're making. But so here's the thing: when you grow up in Columbus, you guys don't understand how many options you have. In Coshocton, we had one movie theater, 2 screens. There were 2 movies to choose from, unless you wanted to drive 45 minutes to go to Zanesville. So, we got to move on with the math. But it's on the east side. I'll look it up. It's on the west side of the loop. It's so it's like in Hilliard. do you know the 270 loop? If I say the loop, do you know what I'm talking about? So Columbus is surrounded by one main highway. It's called the loop. It's 270. Kind of does this. It has this weird little like kick in over here by Gahanna. We are up right about here in Worthington. Over here is Hilliard. Up here is Dublin. Over here is Westerville. Over here is Gahanna. Down here is Grove City. I mean, these are all approximate. Movie Tavern's over around here in Hilliard. AMC Easton is over here at Easton. Polaris Rave is up here, up north. So depending on what direction you want to drive, you've got choices. Down here in downtown, there's a ton of choices because it's right by main campus for OSU. All right, moving on. Charlie got it. If we have an equation that P equals 4S, this is our equation for perimeter. Now, if it's 4 times S, and S is my side length, we know that this has to be a square because all my sides are the same. So, what is the perimeter of a square? Of a square with a side length of 1.6. Write out your work. You should not need a calculator to solve this. Just break up your multiplication. Question or answer? Anybody got questions? Think of a hand, please. Jasmine, do you see that your styling hair made the video on the front page of the Worthington? If we have time at the end of class, make me show you guys the video that some of you were featured in. Actually, Sam's in the video, like solving a problem at the board. Do you remember that day when those people showed up with the camera and they were just like, "Hey, can we talk to you?" Yeah, Mr. Taylor. So, hold up. Bring it back. Just remind me at the end of class, Whitney, how do I set this up? What am I inputting for? Am I plugging in this 1.6 for the P or for the S? Yeah, so this is the side length. It's going to plug in for my S. So my equation now becomes P equals 4 times 1.6. This is another reason why we use parentheses. If I don't want to write my multiplication using the multiplication dot, I can just use parentheses to say a number right up against parentheses is going to tell me to multiply. Break up your multiplication. What is 4 times 1? What would be 4 times 6? Forget about the decimal for a second. 24. Bring your decimal back in. It's 2.4. Add these together, and we get 6.4 meters. You gotta bring over the label from your input value. So now my perimeter is 6.4 meters. Any questions how we solve problems like this? Manasa. Yeah.
The number would always be the constant of proportion.
Yes, because that is constantly how the two values are proportional. So, I've been waiting for an intro like this. Gatorade? No. Gatorade versus vitamin water.
Vitamin water.
I'm not asking for your opinion. Sorry, but I don't really like either of these that much. Gatorade, one bottle, and I like that the serving size is one bottle. They used to make the serving size 8 ounces, which was really annoying. So now they've made it one bottle. Both of these bottles are 20 ounces, so they're the same amount, right? If I drink a bottle of Gatorade, I'm taking in 140 calories. So, you know, your daily amount of calories is supposed to be about 2,000 more for you guys because you're growing. Vitamin water is supposed to be really healthy, right? You'd expect it to have a lot less calories. How many calories do you think is in a bottle of vitamin water?
1,000.
So this was 140, right? This is 120. So if I wanted to compare how many calories I would get from drinking a bottle each day, let's say the calories I'm going to take in will be, for vitamin water, 120 times the amount of bottles. For Gatorade, it would be 140 times however many bottles. So let's say I drink a bottle every day for a week. Compute how many calories for vitamin water compared to how many calories for Gatorade.
Are we talking about 5 or 7?
Ah, a whole week, 7 days, right? So now if I drink 7 bottles, this becomes times 7, which I could use parentheses if I want to make that look nice. If I do that for my vitamin water,
940.
now which one are you solving?
Talking about vitamin water.
The 120 times 7? This is
Yeah, it's
840.
What is vitamin water?
It's just like a drink that's got some nutrients in it and stuff. It's supposed to quench your 980. So each bottle, not that much different, right? 20 calories per bottle, not that much different. But in a week, if I drink a bottle every day, now I've got a difference of 140 calories. Which is a whole Gatorade worth of calories. So if I drank vitamin water instead of the Gatorade, I could drink another vitamin water and still have less calories than the Gatorade. So this is where the practical math comes in, and a lot of adults like diet, where they like count calories or whatever else, they're trying to like lose weight and do these things. It all comes down to the math. It really does.
Vitamin water is better.
So back to our math. Speaking of calories, a certain vegetable dip contains 60 calories per serving. 60 calories per serving. What do you notice if you have a per serving? What is that? That would be, Ellie, a unit rate. So I would notate that we have found our unit rate because it says per serving. And if I was going to underline that, that's like your bells and whistles that tells you it's a unit rate. I want you to set up the number of calories Y in X amount of servings. Now, I normally get the question, can I just change my variables? No, because we want you to get used to Y being the dependent variable and X being the independent variable. This is because, can I just decide how many calories I eat?
Yes.
I mean, if I wanted to think really, really hard, but then that would control how many servings I would be able to eat, right? Can I decide, pretty easy, how many servings I eat? And then calories will be determined by the servings I eat. So my X is independent because I make the choice. The amount of servings I eat does not rely on the number of calories, but the number of calories relies on how much I eat. So I try to set up the equation and then try each of these to see how these are different situations. Each of these is a different situation. So that's where dieting comes in. If you said you wanted to eat 180 calories, then you would go look at how many servings can I have, but that would kind of flip the problem around. Like now your independent variable is the number of calories I'm allowed to eat. Your dependent would be how many servings can I eat to get that many calories. What we're looking at here is how many calories do I take in after I eat a certain amount of servings. Especially food, any food at all, not just cooking. What's up? Okay. All right, let's keep moving forward. We got some people making some breakthroughs. Mr. Hoover, how'd you set up our dip problem?
So we put Y first because we're trying to find out the calories.
Mm-hmm.
Equals 60 because that's 60x, and because x is how many servings, and 60 would be the unit rate, so we're doing unit rate times the
Yeah. Notice we have unit rate times units. Because it's my unit rate, I want to input how many units I eat. Now, Mamasa asked me a question about the second one here. At a telephone, a volunteer can take 60 calls in 5 hours. What equation represents the number of calls why a volunteer can take in X hours. Now, Monica, when I looked at your paper, you didn't have the 60 or the 5 on there. Why?
Because 60 would not, over 5 is not a unit rate.
I need to figure out my unit rate based on what they gave me. So what'd you do?
Divided 60 by 5.
I want my unit rate, which is going to be calls per hour, since I want my hours to be my input. That has to be the denominator of my unit rate. So I need to take my 60 divided by my 5, and we get 12. And Mom, so what's your equation become?
Y equals 12x.
Your equation here should be y equals 12x. You can put the multiplication dot, or you do not have to, because we know if a number is right against a variable, it is multiplication. Sam, take us home with the last one.
Okay, since 60 keys in 12 minutes is not a unit rate, you have to make it a unit rate.
So what'd you do?
I divided 60 by 12.
And what'd you find?
5.
So if you divided 60 by 12, then what you found is 5 keys per minute.
Yep. And then I set up my equation y equals 5x.
Pay attention that her per minute, her input has to be minutes. So since it's per minutes, I have to multiply by the number of minutes. So this becomes y equals 5x. Any questions with how we're setting up these equations? Come on.
What if, like, when they gave us the rate, they had given us the number of keys in seconds or hours?
Then your plug-in would have to be seconds or hours. Like it would have to match the unit that you use, or you'd have to convert to whatever unit you want before you do the math. Now here's the other way I can set up an equation for situations like this. And if you still have space off to the side, I'd love you to write a couple of these down. If I'm told that I can take 60 calls in 5 hours, I know that calls are on top and hours are on bottom. If somebody asks me how many calls can you take in 9 hours, where would my 9 go? Ellie? In the denominator. And then I'd have to be answering how many calls. So you have to make sure that your bottom agrees with your bottom and your top agrees with your top. Numerator units have to match, denominator units have to match. Now there's actually another way I could do this. Hang on to it for a second. I could set up calls compared to calls, hours compared to hours. So I could set up 60 calls compared to some unknown amount of calls will be the same as 5 hours compared to 9 hours. I have hours over hours, calls over calls. But still, if I did this cross multiplication, like we've talked about, we can solve proportion through cross multiplication. I get 60 times 9, and then 5 times my unknown. I get 60 times 9, and 5 times my unknown. There's a lot of right ways to set these up, but the main way we use is top agreeing to top, bottom agreeing to bottom. Jeremiah, you had a question, I think? Okay, Mom.
So when you're trying to cross multiply and find a number, you can set it up either way so that, but in the end you have to multiply across and then divide by the other.
So be careful saying multiply across. Normally it means straight. If we have a proportion, fraction equal to fraction, we cross multiply and then divide to solve, which we're actually going to do right here. So one way that we could do this would be to find the unit rate, which $2.50 for 5 apples. What's your unit rate?
0.5.
50 cents an apple, right? So we could say y equals 0.50 times x, and we could plug in for x apples. However, what if I then tell you how many apples could you buy for $9? This changes. Instead of knowing my number of apples, now I know how much money I have. So check this out. We would use our proportional setup, and this is the stuff I ask you to do on your homework. We could use 250 for 5 apples equal to, what would my fraction on the right side look like? Anyone I haven't talked to yet? Jeremiah, we haven't talked much.
If you multiply the numerator and the denominator by 2, you can make it into an easier number, which is $5 over 10.
I agree, but I don't need to do that. How much money did I tell you we're going to spend? $9, right? Would that go on top or bottom over here? Where is dollars over here?
Top.
Since dollars is on top over here, my 9 would have to go on top, and then I don't know how many apples. Now I could, hey Evie, that doesn't really work very well. Use this one. I could ask myself, how do I go from left to right in multiplication? But that doesn't work out very nice. So instead, I can cross multiply, and I'm going to write in a space that you should not be writing in, but I would get 2.5 times my A equals my other cross multiplication of 9 times 5, which we know is going to be 45. 2.5. Sorry, I tried to make my decimal point. It kind of got consumed by the 5. Hmm? 9 times 5. So the one cross multiplication equals the other cross multiplication. I believe a lot of us did this in 6th grade. Now hang on. To get the A by itself, all I have to do is get rid of the 2.5. They are multiplying, so I divide. And now we can use my calculator. What's 45 divided by 2.5?
45 divided by 18. It's 18.
I changed the problem. So I went beyond what it said on the paper to say, if you had $9, how many apples could you get to set up a proportional equation?
So wait, this is what we're after.
You're going to need to be able to do both.
I didn't get it.
So we could, question or answer?
Another way to solve the problem.
Okay, hang on to it then. I got to answer a question first. We could solve it like this, right? Find our unit rate and say the money you spend will be 50 cents times the number of apples. But this is only easy if I know the number of apples. If I know how much money that I want to spend, that would actually be the Y value. And I could still use this equation, but I like giving you guys multiple ways to solve it. So I know my money and my number of apples. This is what's given to me in my problem. So then I set that equal to my money or my apples, whichever one I know I can plug in and cross multiply, then divide to solve.
Okay, I got your thing.
Okay.
An easier way to do it would be when you have your y equal 0.5 times x, couldn't you change your y into the number
Yes.
which is 9 and then like divide by
Yes.
0.5 to complete? That's what I did.
But easy is relative. So you're saying the easier way to do it? Sure, you can do that way. I have no issue with that. But does my way work?
Yes.
Do you understand it?
Yeah.
That's what I
just
care.
get why you wrote the cross multiplication and then just go through it.
Because I want people to understand the process. Are you my only student in this class? So should I only care about what you understand? So there you go. Sean. We got hung up with some conference stuff this morning, trying to schedule who was going with what. I have them graded, but I don't have my grades I don't have my grades documented yet. Yeah, so I'll have them done at like AO. If you want them back, you can come get them from me. But I also have a couple kids that still need to finish their test. So if you come get yours from me, I'd probably prefer to just show you your grade because it's quarter 2. I'm not worried about you guys doing that stuff right now. But I don't really want you guys to take them. Yeah, and I could tell you right now like how many you missed and whatever. I just need to go through and document like progressing mastery, whatever. Elena. Yeah, you go ahead.
You could do 9 divided by 2.5, which would be 3.6, and then you could do 5 times 3.6,
Yeah. So Elena just said, if I do 9 divided by 2.5, I find out that the multiplication factor is 3.6, and I can do the same thing on the bottom. That's also another way that works to solve these. A lot of right ways to get to Florida.
But why can't you use Texas as an example, not Florida?
Because Florida is more fun to go to than Texas, in my opinion.
Well, I want to go to
If you are traveling to India, let's say today, one of the teachers that used to work here put a thing on Facebook the other day that said the world is a book. Those who don't travel read just one page, and I thought that was an interesting analogy. So the exchange rate, this is probably not accurate.
It's not.
This was written a while ago. Do you know what the current exchange rate is?
62.
62. Cross this out. Let's use current data. 62.
How do you know that?
Um,
India, I know that they're the
yeah, Manasa has that schema. She's got that knowledge base. If I called my brother and asked him what's the exchange rate in dollars to euros, I guarantee he would know because he works for a Switzerland-based company. They use euros. No, they're not rubies. They're rupees. So, here's the deal. It's a form of currency. So, if you had... How much money do we want to have?
$75.
$75. Not too much, not too little. If you had $75, use whichever method you decide to solve how many rupees you would get. You have $75. Samantha, what method would you be using to solve here? All right, so then what did you plug in to solve for how many rupees you get in the end? Yeah, because this would be the rupees that I get will be 62 times the dollars that I exchange. So this becomes 62 times my 75, and how many rupees do I end up with? 4,650. But you have to realize a rupee is not the same as a dollar. A rupee is more similar to like a nickel. If we're going to compare currency, we just have a lot of currency. Like America, we have a lot of different types of currency. We really have too much. We should get rid of the penny. We should get rid of the dollar. We should make a $1 coin, and all purchases should be rounded to the nearest. Okay, but get rid of the $1 paper dollar. I mean, there's too much paper currency, and round all purchases to the nearest 5 cents. You see, there's seriously no point for the penny. Every penny costs over 2 cents to make. Our currency system is totally jacked up. Andrew?
Also, like, whenever we do, like, conversions, like, in school with, like, American money, or in US dollars, the US dollar is usually, like, more than, it has higher value than others. Isn't some currency in, like, China or, like, Asia, like, more?
Yeah, but you have to realize that, like, you can't compare a yen to a dollar because they're not trying to be the same.
No, I mean, like, in value-wise, what's the highest, like, value?
Oh, I don't know. But the closest, I'm fairly certain the closest that we exchange to most normally is the euro. Like, the euro's fairly close to the dollar.
That's like 1 point.
Can we watch the video?
Yeah, since it was during your class, we'll pick this stuff up when we come back from break. Please keep this, hold up. Keep this handy as you're trying to work on your homework. I'm going to make your homework due date like next Tuesday or end of the day next Monday. I'll make it really long. I don't even have it posted live yet. I'm not going to show all of the interwebs this movie. If you want to see the movie I'm talking about, go check out Worthington School's YouTube.